we'll be talking about converting to standard form. So a quick review of what we've been doing the last few days, which is factoring. So taking your trinomial, or in this case a binomial, and factoring it. So if we see a number in front of the x squared, the first thing that we can try to do is pull out a greatest common factor. Is there a number that we can divide out of each of the three terms? And here you can divide each of these by 2. So what we're left with is x squared, and we'll put the 2 on the outside, plus 14 divided by 2 is 7, so 7x, and then 24 divided by 2 is 12. So we divided everything by 2. We ended up with this right here. And then if we have just the x squared, we can try a diamond problem. So what multiplies to 12, that adds to 7, and that would be 3 and 4. Oopsies. So then to write the factored form, you would have the 2, the x plus 3, the x plus 4. Okay, so that would be factored form for the first one. The second one, you can do a diamond problem. So here we have a negative 36 on the top. There's no x term, so there's a 0 on the bottom. What multiplies to negative 36, that adds to 0, and that would be 6 and negative 6. You could recognize it as difference of square and just take the square root of each one. Either way, it'll be x plus 6, x minus 6 for the factored form. And then our last one, again, we have our diamond problem here. We want to know what multiplies to negative 5, that adds to negative 4, and that would be negative 5 and 1. So our factored form would be x minus 5, x plus 1. Okay, remember why we solve quadratics, to find the x-intercepts, roots, and zeros. So if it says solve, okay, so the first one said factor. But if it says solve, what you do is we're going to take our answers from before, and we're going to find the x-intercepts. Notice this equals 0. We want to know what makes 2 times x plus 3 times x plus 4 equals 0. And we're going to split it up. We're going to use this thing called zero product property, which says if we can make just each one of these 0, it doesn't matter what the other factors are, because 0 times anything is 0. So we want to know what makes x plus 3 equal 0, and that would be negative 3. And we want to know what would make x plus 4 equal 0, and that would be negative 4. So if you can factor it, like we did here, then to solve it, it's just finding the zeros, or what makes each factor equal to 0. So this is actually solving it. If you were to graph it at negative 3 and at negative 4, you would have your x-intercepts right there. All right, so this one right here, again, if you factored it, and we did, it was x plus 6, x minus 6 equals 0. When we graph it, the x-intercepts are just what makes each one 0. So one would be negative 6 and one would be 6. If you were to graph it, it would look something like this. Actually, it would go through that point right there. And then our last one, again, we've already factored it. It's x minus 5. X plus 1, we want to know what makes that equal 0. So one answer would be 5, one answer would be negative 1. And if we were to graph that, at 5 it would cross, at negative 1 it would cross, and our graph would look something like that. So that's solving the quadratic. You can factor it and then find those x-intercepts. So recall, vertex form of a quadratic, and I'll just do an example with numbers. What if we had x minus 3 squared plus 1 equals what? All right, what does the vertex of this form tell us? It tells us what the vertex is, where the graph changes direction. And here the vertex would be 3, 1. It's the opposite of what's in this parentheses, and it's the same as what's on the outside right here. So this is vertex form. If you want to see like the standard form, what they read it with letters is x minus h squared plus k. So you'll see a squared, and then you'll see some number on the outside, and this is shifting the graph, and that tells us the vertex, where it changes direction. It's either going to be the max or the min, depending on if it's a smiley face graph or a frowny face graph. It'll be where it changes direction. Okay, factored form of a quadratic. Again, we'll do an example. What if we had like x minus 3, x plus 4, like that? This is factored form. What you'll see it written out as is like x minus, if we used r, x minus r2, where r1 and r2 are the x-intercepts. So the form tells us where the graph crosses the y-axis. So for this problem right here, it would be at 3 and it would be at -4. So if we were to graph it, 1, 2, 3, 1, 2, 3, 4, and you would have your graph, your parabola. And then lastly, standard form of a quadratic. This is where it's new. And I mean, we've been looking at this form before. It's just when it's written out. So it's ax squared plus bx plus c, where a, b, and c are the numbers. So this is when it's written out. There's no parentheses. Standard form of a quadratic. We'll learn about what this form tells us soon, but the goal is, can we get it to standard form using vertex and factored form? And all it is multiplying and combining like terms. We've actually already done factored form before in day 6.5. Here's another example. The local youth club has a stage for karaoke competitions. The main stage is a square. The tech crew needs to increase the length by 2 feet and the width by 1. A plan for the stage is shown below. Can you write expressions for the area for each part of the stage? All right, so the main stage would be x squared, x times x. The sound part would be 2 times x. The light part would be x times 1, or 1x, or just x. And the storage part would be 2 times 1, or 2. So you're finding the area of each rectangle. And then if we add it together, you can combine like terms right here. So we get x squared plus 3x plus 2. And that, again, is changing from factored form to standard form. Again, we found the area using the area model. We know x times x is x squared. We know how to multiply this out. This would be x squared, 5x, 1x, and 5. And again, just changing it to standard form is just combining like terms. Here's standard form. So we've done that, and again, we've practiced it. It's said on Delta Math expressed as a trinomial. And so we've practiced writing this out. X plus 5, x minus 7, and then multiplying each part. X times x is x squared, 5 times x is 5x, x times negative 7 is negative 7x, and 5 times negative 7 is negative 35. Combine like terms, we get x squared minus 2x minus 35. You can do it when there's coefficients or numbers in front of the x's. So for this one right here, we have 3x minus 1, 2x minus 4. Okay, so in our first box right here, we got 3x times 2x, which is 6x squared, negative 1 times 2x, which is negative 2x, 3x times negative 4, which is negative 12x, and negative 1 times negative 4, which is 4. Combining like terms, we'll get 6x squared minus 14x plus 4, and this is standard form right here. A is this number in front of the x squared. This is considered our A value. B is this negative 14 in front of the x squared. And C is this number by itself. And that's where you see this in standard form, like with that ax squared plus bx plus c. So there it is, multiplying it out. You can also go from vertex to standard form. So if I said, what's the vertex of this function? It would be negative 5, 10. But if I asked you to multiply it out into standard form, here are the steps. Multiply, do the exponents first. All right, so here's the first part. We're going to do x plus 5 times x plus 5 first. We'll get x squared 5x, 5x, 25, which leaves us with x squared plus 10x plus 25. Our next step is distribute if there's an a value. Okay, this a value is the number in front right here. So we'll distribute that to everything inside the parentheses. Negative 2x squared plus 10x plus, I didn't distribute. All right, so negative 2x squared. Okay, so it's negative 2 times 10x is negative 20x, and negative 2 times 25 is negative 50. All right, so there's distributing that number in front. And last step, if there's a k value, you add or subtract it. Here's the k value, this number by itself, so we're going to add 10. You can only combine it to the negative 50. The final answer is negative 2x squared minus 20x minus 40. So that's changing it to standard form. So we'll try two more again. Steps are the same. First, we do our exponents. X plus 8 squared. Okay, so we have x squared, 8x, oopsies, 8x 64. So we'll combine like terms. Next step is distribute this number in front. And here, if you don't see a number, there's an invisible -1 there. It just makes everything the opposite sign. So negative x squared minus 16x minus 64. And then last up, there's this k value, this number at the end right here, this -3. So we'll combine it and get negative x squared minus 16x minus 67. And there's our answer in standard form. All right, so in class, I'll have you guys try at least one on your own, and I'll work it out right here. First step, x minus 1. We got x squared minus x plus 1. Next step, we'll distribute the 4. So we'll get 4x squared minus 8x plus 4. Last step, we'll look if there's a k value here, that's plus 6. Combine like terms, and we'll get 4x squared minus 8x plus 10. So your assignment today will be practicing converting this to standard form, and then we're going to review all of these topics when we come back to class.